This is going on your notes from Friday. Taryn, weren't we on example 4? Thank you. All right, so let's start off with a log equation that we have to do some work with. But if you are, no, that's okay. I love those questions. I think some teachers used to get mad at y'all and be like, you just need to know it. I like those questions. If you are an engineer, you will use them. Granted, there's computer software that will do a lot of the calculations for you, but they use them. Architects use them sometimes, just depends what kind of object you're building. Math teacher, obviously, we use all the fun stuff. If you like major in mathematics and you do statistics stuff for a business, you might use them. Just depends. Does that help answer a little bit? Okay, cool. All right. What's different about this equation?
Bases are different.
The bases are different. Does everybody see that? You can't condense these. They are not the same. You can't just put them together. So what do? Make the bases the same so we can condense it and put it together. Very good, Kevin. How do we make the bases the same? Yeah, so it's going to be, what base do we want? Which one's going to be easier to use? The smaller one. So what Maddox and Kevin are both saying is we can do log base 2 of x over log base 2 of 8. What is that formula called? Change of base. Do you guys remember me showing you how to do this Friday? And y'all were like, oh, this is so easy. And I was like, hold on to that thought till Tuesday. Because y'all all of a sudden think it's crazy hard when we put it into solving an equation. Okay? I'm going to make the bases the same. So watch. I don't need to change this one. It had the smaller base, so I'm just going to leave it. This is going to become minus log, we want base 2 of x over log base 2 of 8. That is your change of base formula. And something super awesome is going to happen here. And I'm hoping people will see it. Because these actually aren't that bad. You just have to remember how to change the base. Katie, can you see that green okay? Okay. You're like, yes, she's writing big as crap. I can see today. Are we ready for the magic? This is the cool part. You ready? 2 to the what power gives me 8? No, not 4. The denominator is just 3. That should always happen when you do change a base. It should become a whole number. No, it's not always a 3. You can see 2s, 4s, 3s, 5s, 6s, whatever. Are we okay with that? All right, next step. This is going back to day 1. Before I even condense, because now they have the same base and I can condense, right? Before I even condense, there's something I want to get rid of because I don't like the way it looks. Good. What's the opposite of dividing by 3? Multiply the entire equation by 3. Have I lost anyone? Colin, quit writing on your arm. Write in your notebook. Boys, man. I hope I have nothing but boys. I don't think I could handle girl children. Huh? All right. What do we do now? Good. Distribute the 3. So this is 3 log base 2 of 3x plus 2. Are we okay there? Okay. Minus, what happens with these two 3s? Yeah, that was the whole purpose in multiplying by 3 is they cancel. So minus what? No, why are you saying 3? My 3's are gone. Those two canceled. Perfect. Log base 2 of x equals, good, 3 times 3. Don't forget this back 3. This is the one y'all always forget, and it messes up your entire answer. And no, I cannot give you partial credit on that. What is 3 times 3? Great. Have I lost anyone at home, or y'all are good? Yoo-hoo.
I'm good.
KJ's good. Kelly, Ross, Oswald, Sydney, Natalie, Javion, Mary, Drake, Prania, Mariana, Brody, Ann, y'all are good?
Yeah.
All right.
Yeah.
Yeah, I'm good.
There we go. Why was that so hard? Answer me, you fools, or I'm going to throw stuff at you when you get back here next week. What do we do now? Condense. Don't they have the same base? Condense them. So this 3 is going to become the exponent. And if we're subtracting, what am I going to do with the 2 arguments? Divide them. Very good, Cody. Extra credit. He's doing so good. Cody, this is what we were talking about this morning, since you wanted to know so badly. We're about to get some big numbers, but it's okay. We'll figure it out. Y'all okay with this? Now that you have 1 log, what can you do? Loggy froggy. It's the same thing from last week. So 2 to the 9th is going to equal this argument. So I'm going to do 2 to the 9th equals 3x plus 2 cubed over x. No. Base of 2 raised to the 9th power. Yep. I'm thinking 2 to the 5th is 32. So to the 6th is 64. To the 7th would be 128. To the 8th would be 256. So to the 9th would be 512. Yeah. And y'all are like, why did she just do that in her head when she go type it in a calculator? 2 to the 9th is 512 equals 3x plus 2 cubed over x. And I do want us to stop there because I want us to talk. Did I lose anyone, or you guys are okay with this? We're okay? Only thing that's different is we had to use change of base to change the bases, and then we got rid of that one denominator, okay? All right. Normally, I hope you heard me say normally, you will not end up with a cubed function. Does everybody agree this is x cubed? This is a cubic function? Okay. In pre-cal, we do not do solving cubic functions by hand. Y'all did that in Math 3. Maddox probably asked, when will we ever use this in Math 3? I don't have a good answer for that because nobody solves a cubic function by hand in the real world. We all use technology, even me. Okay? So if you see something crazy like a cubic function, I'm going to show you how to put this in Desmos. Does that sound good? Now listen to me carefully. If it is a quadratic function, and why do you think I'm telling you this? Because it's on the test. If it's a quadratic function and it says solve algebraically, you best get to factoring. Do we understand? But I feel like y'all know how to factor, so that's why I did a weird one like this in the notes, okay? Yes, we're okay. All right, so check it out. If you get a cubic function like this, we're going to go to Desmos. So let me pull up Desmos for my at-home babies. Oh my, it didn't like that. There we go. All right. And this is what I want you guys to type in. Who remembers how to type that into Desmos? Kevin, what do you think? I'm just typing what you said. Uh-huh. Oh, hang on. You can just click the down arrow. Oh, extra credit. Thank you, guys. Okay. Equals y. Okay. Ooh, y equals 512. Okay, so that's the first way you can type it in. So they just typed in the two equations, each side, and we're going to see where they do what. Good. What is this called when I have two equations and I'm seeing where they intersect? Good. System. I have to teach that to my Math 1 kids next week. Pray for me, because right now they having trouble graphing lines. And I'm very sad. Oh no, not zoom in, zoom out. Till we hit 512. Here we go. Oh, there's two solutions. Let me zoom that in. Oh, is that 3? No, one of them's the y-intercept. The dark red is the y-intercept. All right. So the first answer for x, people at home, is that negative 5.32. The second answer for x is 3.31 if I round it. Are y'all okay with that? Okay, the second one is the y-axis. The third, this, like the one in the middle? This one. Let's see. Zooming out is not going to help me. Oh my God, and I did it anyways. So if it's cubic, so if it is cubic and it is divided by x, basically what's going to happen, and I'm going to scroll all the way up so y'all can see it. If it's cubic, it should have 2 turning points. So it turns twice. Does that make sense? You can see up here. There's also, this is getting into next unit, but I do want you to see it. There's also an asymptote here because x cannot equal what? Very good. So it's got a turning point, there's an asymptote, and then there's the other piece. Okay? We'll get into that next unit though. What you need to know for this unit, switch back. I'm so proud of myself for doing pretty daggone good off my medicine. Is these are my two x-intercepts. Now, which one is extraneous? Now listen to me carefully. The negative is not always extraneous. You need to actually go put it into the log and see if it stays negative, okay? So when I go back up to the top with negative 5.32, that is going to stay negative in both of these logs. And can the argument be negative? No, so that one is extraneous. So what's my answer? Good. Did that seem too hard? You guys feel like you can change the base and solve the equation? I'm not giving you any crazy ones like this from here on out. There might be one on the exam. Highly doubt it, but there might be, which is why I showed it to you, okay? All the other ones will either be linear or quadratic, and you should be able to solve them by hand. Sound good? So do I need to do another one, or you guys feel like you're okay? Okay. You'll get like practice time in class to do some. All right. So example 5. These are my favorite, and you guys always freak out. Which I kind of get because it's very weird at first. KJ, this is what you saw me helping Carly and JJ and AJ with last year. This is when me and KJ first met in a store, and he was like, I hope I get you for pre-cal. And I was like, you're sweet. And it worked out that way. Right, KJ?
Yes, ma'am.
He just says yes to everything. So sweet. All right. I'm looking at you, Katie, because I'm seeing if you'll freak out on me or if you're going to think through it. My week A kids would have freaked out. I'm waiting for them to say something. All right. What kind of equation is this? Good. On your quiz, some of you missed the graphs because there was something like this and you said it was logarithmic. Do you see a log? Then why did you say it's logarithmic? What do you see? Exponents, which means it's very good. Think about an exponential equation. What is our goal? What are we trying to do first? Get the bases the same. All bases the same, right? Can you write 9 as a base of 3? Sure can. What do we write?
3 squared.
Okay. No, I know that's what you meant, but I was like, come on, Kevin. 3 squared is 9, right? This is very different from anything you have seen. I need you to understand that, okay? You have to be open-minded. Please don't say what and close your mind off, because as soon as you start freaking out, your mind cannot think properly. Sound good? All right. What kind of function besides exponential, because we already established it's exponential, but what kind of function does this look like it's kind of mimicking? Good. Why are you guys saying quadratic? You are right. Why? Okay. Yeah. I need something else. There's something I see that makes me go, ooh, this could be quadratic. Hang on, what? You said it's set equal to 0. That's one reason. There's 3 reasons. There's 3 terms. Second reason, there are 2 exponents. That's half of the third reason. What's the first exponent? 3 squared times x, right? But it's 3 squared. So you can rewrite this as a quadratic, okay? We're going to make it look like a quadratic. I'm just telling you what we're going to do so you're not like, where the heck is this coming from? Make it look like a quadratic. Then what should we be able to do? Factor it to solve it, right? These are actually easier than other ones because there's no taking the logs of both sides. You cannot take the log of both sides of this, okay? Let me show you why. Every year I have a kid ask me if they can do this. Please don't do this, just watch. So they do this, then they always do this. And then they're like, and then can't we do loggy froggy? Why? What did they do wrong? Why? You're right. They added, Kendall said, you can't add those exponents. I said, why? Come on, my smart, brilliant boys. You said it. What was somebody at home saying? I'm gonna see if you got it for your extra credit.
Because it's a plus sign. It's not.
Good. That's what Kevin said too. You cannot add exponents when you're adding. When do we add the exponents? When you're multiplying, you can't do that. We're not multiplying here. So there's no getting a same base, trying to put it together. It doesn't work. Very good, Anne. Very good, Kevin. Very good, the rest of you, because you were thinking it through. That's good. We need to write this as a quadratic because we're adding and subtracting. We're not multiplying or dividing, so we can't do anything with our exponents, okay? So just watch what I'm going to do. Actually, no, I'm going to make you think about it because it's more fun for me. What do the 2 of these have in common? They both have a 3 and there's something else. And they both have an x. Good. So watch what I'm going to do. Close, Cody. Yes. Basically, I'm taking out the 3 to the x. Basically. This is where I tend to lose people. So if this looks weird, ask me a question. All right, do we agree if I'm going to use takeout because I liked that. If I take out the 3 to the x in the first one, I'm left with the 2 and the exponent. Okay? If I take out a 3 to the x in the second one, y'all look what we're left with. You're left with a 3 squared, right? Does everybody see that? Why did I write a multiplication sign? Because the exponents were adding. So I'm multiplying by 3 squared and then minus 10. Now, let's reduce it even more. What's 3 squared? So I have 3 to the x squared plus 9, 3 to the x, minus 10 equals 0. We okay? All right, Chloe, I haven't talked to you a lot today. Pick a letter, any letter. B works for me. Everybody make 3 to the x B. Put something in to hold its place. You can put a heart, you can put a star, you can put a T for Taryn, you can put a D for Daniel. I don't care what you use. Put something in to hold the place of the 3 to the x. Why do you think I told you to put in a placeholder? Good, you can't factor 3 to the x. And it also just looks crazy. That's the other reason, but you also can't do it. But if we rewrite it with letters, y'all know how to factor this. What are my 2 factors of b squared plus 9b minus 10? Okay, I heard b plus 10, and I heard the other one would be b minus 1. Do I need to go over with anybody how to do that? No, y'all remember how to do that for math too? So we've got, you're good. So it's a negative 10, which means I need factors of 10 that subtract to give me 9. That would be 10 and 1. If I want a positive 9, the 10 is positive, the 1 is negative, because I needed a negative, so the sign should be different. So then when you solve it, b plus 10 equals 0. That means b will be negative 10, right? You should have learned in math 1 and math 2, the shortcut is just to flip the signs. And then if b minus 1 equals 0, that means b would be 1. Are we okay? Are you sure? Now we're not done. We've done the hard work. The hardest part is right here. If you can get here, you are golden. That is the hardest part, okay? I didn't start out with having b's. What did I put b in place of? So 3 to the x should equal negative 10, or 3 to the x should equal 1. Those are my 2 options. So then you solve for x. Very good. Which one won't work? Why? Tell me why. Good. You can't put anything to a power and get a negative, right? Because even 3 to the negative 10th would be 1 over 3 to the 10th. It's not going to be negative. It's still positive. This one will never work. 3 to what power will equal 1? So what's our answer? Look at y'all. How do you feel about that? Okay. Can we do one more where we just practice setting it up, and then I'll let you start your homework? I just want to make sure we can all rewrite it as a quadratic, because there is 1 or 2 of these on the homework, okay? And there's one on the test. We go with this. People at home, are y'all okay?
Yes.
Thank you, Kel. All right.
A question.
Okay.
I don't want to use b. Can I still use 3 to the x?
What'd you say, Ann?
If I don't want to use b, can I still use 3 to the x?
Yeah, if you can visualize that as a quadratic, I almost hit myself in the face with that. Holy crap. If you can visualize that as a quadratic and factor it, then I'm okay with that. Yep. All right. Last one. then you can start your homework. So sweet, he brought me the whole folder. Not what I needed, but that's okay. All right. This one's even easier because what? What did I give you? Merry Christmas, Happy Halloween. I gave you the same base already. One less step, right? What do these two have in common? The 2 and, yes, they both have a base of 2 and they both have an x in the exponent. So this is where you should notice, okay, 1, it's set equal to 0. 2, there's 3 terms. 3, the first one looks like it's being squared. Oh, that's quadratic. Does everybody understand that? I think a lot of you are working ahead of me, which is fine. That means you get it. That's good. So I'm rewriting this 2 to the x and then squaring it, because that would be what would be left. I'm taking out the 2 to the x like Cody said. Cody, I've never had a kid say that, and I really like that. It's a good way to explain it. Like when you said, like, we're taking out 2 to the x, none of my students have ever said it like that. And I like that. That makes a lot of sense with what we've been doing. So extra credit. Good job. You got 5 points today. Are you guys okay with how I rewrote this? Do I need to explain anything? Remember, if you're adding that squared exponent, that means we were multiplying the 2 bases, right? That's the only part that y'all usually get confused on. All right, Daniel, pick a letter. M. I'm going to put in M instead of 2 to the x. And what's 2 squared right here? So this is going to be 4m minus 12 equals 0. Good. Factors of 12 that subtract to give me 4 will be 6 and 2. M squared is m and m. Which one's positive? Which one's negative? 6 is positive, 2 is negative. So what are my 2 values for m? Good. Are we done? Please, please, this happens every year and it breaks my heart. Do not type in -6 and 2 into Desmos. That's wrong. Okay? It's not the answer because we didn't have the m's to start with. What is m in place of? 2 to the x equals -6, or we can have 2 to the x equals 2. Can't get anything raised to a power to equal negative, so 2 to the what equals 2? So x is 1. Y'all feel good with this? Fantastic. People online, do not leave. Let me tell you which problems you're doing for homework, because some of y'all never listen to that and you do the whole thing. So unless you want to do 18 problems for homework, I would listen. All of y'all were like, oh yes, I will listen. I don't want to do 18 problems. I gotta look at mine real quick and see which ones I definitely want you to do. Ooh, that's a good one. Yep. Okay. Everybody ready? Yes? Okay. I want you to do on the front side 10 through 12. So on this side that y'all are about to get, people at home, on the first one, you're just doing 10, 11, and 12. Does that sound fair?
Yes.
I'm going to be even nicer. You can just do 10 and 11. You're welcome. 10 and 11. On the back, I do want you doing all of them. It's only 6. So you have 8 problems total.